in this video, we're going to solve partial fraction integrals. And I have a intro to this concept if this is totally new to you, but if you're a little bit familiar, then this is a good place to start. What we're doing here is that this integral is difficult to take. So what we're gonna do is try to rewrite this as one of the basic rules of integration, something that we can take, right? That is what you do in Calculus 2. Every fancy trick that you learn is serving the purpose of never solving this integral, instead doing algebra on this and trying to make it look like one of the 20 basic rules of integration that you learn in the beginning of Calculus 2. Because those are the integrals we know how to take, and even with integration by parts, effectively, those are the integrals you take. You don't take the ones that are difficult. That's why you change the du to dv. Okay, so I'm going to rewrite 1 over x squared minus 9 portion only and work on that. So here we have a difference of squares. I'm going to factor, and this is what it equals to, right? That's the same statement. X squared minus 9 is same as x minus 3x plus 3. All right, so this is in a single fraction form. Now I'm going to split it and put it in a product of two fractions. The same thing though, because if I, combined it, it would be the same exact as this. So I haven't done much. But what I want to do is way more ambitious than putting a product there, because product does not help me at all, because if I do integral here, then product, you can't take separate integrals of product. You can if there was addition or difference, but not if there's a product. So can I just, reach for the stars and put plus there instead of product? Not really, but who's gonna stop me? I'm gonna do it. What I'm not gonna do is completely go off the rails and put ones there. No, I'm not gonna be that obnoxious. Okay, so I'm gonna put plus there, but I'm gonna say that I don't know what the coefficients are. And I want to, keep in mind that when I put these fractions together, there's a plus here. You have to find a common denominator, which will be the product of these two, and give this one x plus 3, because it's lacking that. It has x minus 3, so it needs x plus 3. Give this x minus 3 and put it together. You put that together and you're gonna get 2x, not 1. That needs to be 1, because the denominator will certainly be x squared minus 9. So the top part has to be 1. So I'm not going to say that these are 1. I'm going to say that these are some numbers, and I'm going to call them a and b for now. And a and b because I don't know if a equals b. If it does, it does. But I'm not going to assume that this number is the same coefficient as that. I'm not going to assume that. It's a lot of assumptions, and I'm not going to be that type of person. Okay, so let's get the common denominator. You multiply a by what it lacks, and that is x plus 3. And you multiply b by what it lacks, which is x minus 3. Okay, so this side of the equation needs to equal that side. Again, we don't have to worry about denominators. We do need to worry about the top part, denominators. So I'm not going to drag around denominators. I'm just going to concentrate on the denominator and work on that and try to find a and b. Because once I find a and b, then I can write this integral as the sum of two fractions dx, take integral of first fraction, second fraction, and be done. So a and b is what you're finding with partial fraction decomposition type of integrals, okay? So the way that you can find it is, there are several different ways. The easiest and fastest is by eliminating b term and finding a, and then eliminating a term and finding b. And the way you do that is you realize that x can take on any value, right, as long as it's a real number. So you choose x to be, for a little bit, something that turns this whole thing 0, so that you can have b times 0. So you get rid of b. And if I had 3 here, that would do the job. So let's set x for, or I would say finding a, finding Nemo. X is 1 for a little bit, okay? And wherever you see x, oh my goodness, I said 1. No, that will not get me anywhere. I mean, you can set x to 1, but that's not going to get you far. So that's going to eliminate that part, which is what I wanted. So then what do I have left? A times, and that's 6, right? So how do I find a? A is 1 over 6. Okay. And now finding b. Now let x be. Let's see what will get rid of this. Okay, if this was -3, a term goes away and I can focus on finding b. So let me just for a minute allow x to be -3. Okay, and wherever you see x, in this case, put -3 there. See what happens. This goes away, so I can focus on finding b. What I'm left with is b times -6, and then b equals 1 over -6, or just -1 over 6. Okay, so I found my coefficients, and that is all I wanted to do. That's 1 over 6, and this is -1 over 6, okay? So then you put that instead of 1 over x squared minus 9. And what happens now, I mean, you don't have to write this step, but really what's happening is that you give this its own dx, take that integral separately, take this integral separately. 1 over 6 is a constant. So it comes out of the integral. Let me get this down here so we can solve this integral with a little more room. Okay, so 1 over 6, the first one, positive 1 over 6, comes out of the integral because it's constant. I'm left with 1 over x minus 3. Treat that as if it was 1 over x. Integral of 1 over x is ln, okay? Why can you treat that x minus 3 as if it was x? Because if you assign that to be u, then du is derivative of x minus derivative of 3, and that is just 1 du. When dx equals du, you can just neglect u substitution and treat this whole boom as a 1 unit as if it was x. So ln, and minus 1 over 6 comes out, and ln x plus 3. And that's your final answer. You can stop there, or you can simplify it, understanding that there is this is using log rules. So this coefficient, when it's in front of log, comes here as the power. And whenever you have a minus sign between logs, then this is the numerator, this is the denominator. It's a division. So whenever you have an addition in log world, that's multiplication. So you can combine that and say x minus 3, the one that has positive sign goes in the numerator, and one that has the negative sign goes in the denominator. Okay, and that's your final answer. You box that and you're done, okay? So partial fraction decomposition is useful because you can take that integral. That's a hard integral to take. You can take this basic integral, so you make this look like one of the basic rules of integration, like ln, you know how to take 1 over x, And you can do this legally as long as you find fair coefficients that whenever you put this fraction together, you can try it here. In fact, let's do that. So imagine if we don't get 1 in the denominator. Of course, we are going to get it, but imagine, that would be so funny. Okay, so 1 over 6 times x plus 3 minus 1 over 6 x minus 3. Okay, let's do step by step, not make a mistake. Plus 3 over 6, 1 over 2 minus 1 over 6x plus 1 over 2. Okay, I was like, oh my goodness. All right, x minus 3, x, I don't know why I'm so nervous, but as one should be. Okay, so these get canceled, and 1 over 2 plus 1 over 2 is 1. And then the denominator is, we were never concerned about the denominator, right? We were only worried about the numerator. So these are the coefficients that would end up giving you 1. So that's what you need to find with partial fraction decomposition, okay? And it gets harder than this because I'm going to record another video which is going to be mastering partial fraction integrations. So there we'll do the actual hard stuff. But this is not bad. Thank you so much for watching. I hope this was helpful. Bye.